There's been talk about comets in the news lately, and we've had a few decent comets in the last few years. In this episode, we'll explore what comets are, where they come from, how to observe them, and their rich historical and cultural significance. Whether you're a seasoned stargazer or a curious beginner, there's something here for everyone. So let's embark on this cosmic journey and uncover the secrets of comets together.
Welcome to the AstroGuy Podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
Welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl. In this episode, we're diving into the fascinating world of comets. So, what exactly are comets? Let's start with the basics. Comets are often described as dirty snowballs or icy dirt balls. They're small, solar system bodies that, when passing close to the sun, heat up and begin to outgas, displaying a visible atmosphere or coma, and sometimes a tail. This process is known as sublimation, where the ice changes directly from a solid to a gas. Now let's break down the main parts of a comet. First, we have the nucleus. The nucleus is the solid, central part of the comet, composed primarily of water ice, frozen gases, dust, and organic compounds. Despite being the heart of the comet, the nucleus is relatively small, typically ranging from a few hundred meters to tens of kilometers across. It's often irregular in shape and dark in color because it contains a lot of dust and rocky material. When a comet gets close to the sun, the heat causes the ice and other volatile substances in the nucleus to vaporize and form a cloud of gas and dust around the nucleus. This is what we call the coma. The coma can grow to be tens of thousands of kilometers across, making it much larger than the nucleus. The sunlight reflected off the coma is what makes the comet visible to us here on Earth. One of the most striking features of comets is their tails. Comets can have two types of tails, an ion tail and a dust tail. The ion tail, also known as the gas tail, is made up of charged particles or ions. This tail always points directly away from the sun, no matter which direction the comet is moving, due to the influence of the solar wind. The solar wind is a stream of charged particles emitted by the sun that sweeps the ion tail away from the comet's nucleus. The dust tail, on the other hand, is made up of small, solid particles. Unlike the ion tail, the dust tail is curved and follows the comet's orbit. The sunlight pushes these particles away from the nucleus, creating a broad, diffuse tail. Sometimes the dust tail can be seen with the naked eye, especially when the comet is bright and close to Earth. But what makes comets different from asteroids and meteoroids? Well, the primary difference lies in their composition and location. Comets are rich in volatile compounds like water, ammonia, and methane, which form their spectacular comas and tails when heated by the sun. Asteroids, on the other hand, are mostly rocky or metallic and do not exhibit the same outgassing behavior. They tend to remain relatively inert and are mostly found in the asteroid belt between Mars and Jupiter. Meteoroids are much smaller fragments of comets or asteroids that become meteors when they enter the Earth's atmosphere and burn up. To recap, comets are small solar system bodies composed of ice, dust, and organic compounds. When they approach the sun, they heat up and form a glowing coma and tails, which are some of the most stunning sights in the night sky. They are distinct from asteroids and meteoroids in their composition and behavior. Understanding these basic components of comets sets the stage for exploring their origins, how to observe them, and their rich historical and cultural significance. Now, let's explore where comets come from and their journey through the solar system. Comets originate from two main regions in the solar system, the Kuiper Belt and the Oort cloud. The Kuiper Belt is a vast donut-shaped region beyond Neptune's orbit, stretching from about 30 to 55 astronomical units, or AU, away from the Sun. For context, 1 AU is the average distance between the Earth and the Sun, roughly 93 million miles. The Kuiper Belt is home to many icy bodies, including dwarf planets like Pluto and Eris, and short-period comets. These comets have orbital periods of less than 200 years and are thought to have formed in the early solar system, remaining relatively close to the Sun. The Kuiper Belt was named after Dutch-American astronomer Gerard Kuiper, who made significant contributions to our understanding of the outer solar system. Although Kuiper did not predict the existence of the Kuiper Belt himself, his pioneering work in planetary science laid the foundation for its discovery. Kuiper was instrumental in the discovery of several moons of Uranus and Neptune and hypothesized about the existence of icy bodies beyond Neptune, which ultimately led to the identification of the Kuiper Belt. In addition to his work on the outer solar system, Gerard Kuiper discovered Miranda, one of Uranus's moons, and Nereid, one of Neptune's moons. He also made significant contributions to our understanding of the atmospheres of planets and moons in the solar system. His work continues to influence and inspire astronomers today. The Kuiper Belt remains a crucial area of study, as it holds many secrets about the formation and evolution of the solar system. By studying the icy bodies and comets within the Kuiper Belt, scientists can gain valuable insights into the early stages of our cosmic neighborhood. The Oort cloud, on the other hand, is a vast, spherical shell of icy bodies that surrounds the solar system at distances ranging from about 2,000 to 100,000 astronomical units, or AUs. This remote region is the source of long-period comets, which can take thousands to millions of years to complete one orbit around the Sun. The Oort cloud is much farther away than the Kuiper Belt, and is believed to be a reservoir of comets that were scattered by the gravitational influence of the giant planets during the formation of the solar system. The Oort cloud is named after Dutch astronomer Jan Oort, who proposed its existence in 1950. Oort's groundbreaking work revolutionized our understanding of comet origins and the outer reaches of the solar system. He theorized that the long-period comets observed in the inner solar system must come from a distant spherical cloud of icy bodies, which became known as the Oort cloud. His hypothesis was based on the observation that these comets have highly elliptical orbits, suggesting that they originate from a distant spherical distribution. Jan Oort made numerous contributions to astronomy besides the Oort cloud. He played a key role in advancing our understanding of the Milky Way, mapping the rotation of our galaxy, and providing evidence for the existence of dark matter. His work laid the foundation for modern galactic astronomy and has influenced generations of astronomers. The Oort cloud remains one of the most enigmatic and distant regions of our solar system. Studying comets that originate from the Oort cloud allows scientists to gather valuable information about the early solar system's conditions and processes that shaped its evolution. By observing these ancient icy bodies, astronomers hope to unlock secrets about the formation and history of our cosmic neighborhood. Comets are essentially leftovers from the early solar system, preserving the primordial materials that existed when the Sun and planets were forming. These icy bodies were formed from the same material as the planets, but were ejected to the outer reaches of the solar system due to gravitational interactions. Occasionally, gravitational nudges from passing stars or the galactic tide can disturb comets in the Oort cloud, sending them on a long journey toward the inner solar system. As these comets approach the Sun, the increased heat causes the ices to vaporize, forming the characteristic coma and tails that we observe. This process not only makes comets visible, but also releases ancient material that scientists can study to understand the conditions in the early solar system. Missions like the European Space Agency's Rosetta, which studied Comet 67P Churyumov-Gerasimenko, have provided valuable insights into the composition and behavior of comets. To summarize, comets come from the distant Kuiper Belt and Oort cloud, where they have been preserved since the formation of the solar system. These icy bodies are the remnants of the early solar system and offer a unique window into its history. Now that we've covered what comets are and where they come from, let's dive into how to observe these fascinating celestial objects. Observing comets can be a fun and rewarding experience, and with a little preparation, you can enjoy some spectacular views. First and foremost, it's important to know when and where a comet will be visible. There are several online resources and apps that provide up-to-date information on comet locations, visibility, and brightness. Websites like theskylive.com and apps like Stellarium can help you track comets and plan your observations. When it comes to observing comets, dark skies are your best friend. Light pollution from city lights can make it difficult to see faint objects, so try to find a location away from urban areas. The darker the sky, the better your chances of spotting a comet. If you can get to a dark site, using a telescope or binoculars will enhance your view. Binoculars are a great tool for comet observing, especially for beginners. They're portable, easy to use, and provide a wider field of view than telescopes. A good pair of 7x50 or 10x50 binoculars can help you spot comets that might be difficult to see with the naked eye. Once you've located the comet with binoculars, you can switch to a telescope for a closer look. When using a telescope, start with your lowest power eyepiece to locate the comet, and then switch to a higher magnification to see more details. Comets can appear as fuzzy patches of light, and with larger telescopes, you might be able to discern the nucleus, coma, and even the tails. You can use a light pollution filter, but it may block some of the light coming from the comet, so try it, and if it doesn't help, remove the filter. You can also blink the filter in front of the eyepiece with your hand to try to see if that helps. It's also useful to have a star chart or an app to guide you to the comet's location in the sky. Timing is crucial when observing comets. Some comets are best viewed in the early morning or early evening, depending on their position relative to the sun. Keep an eye on the comet's predicted brightness and visibility window to maximize your chances of successful observations. Observing comets requires a bit of planning and preparation, but with the right tools and conditions, you can enjoy some incredible views. Now we'll explore the historical significance and lore surrounding comets. Throughout history, comets have fascinated and sometimes frightened people, inspiring myths, legends, and scientific inquiry. In ancient times, comets were often viewed as omens or harbingers of significant events. Their sudden and unpredictable appearance in the sky, often with bright glowing tails, was interpreted as a sign from the gods or a precursor to major changes. Many cultures associated comets with disaster, war, or the death of important leaders. For example, the appearance of Halley's Comet in 1066 was believed to have foreshadowed the Norman conquest of England. The comet was depicted in the Bayeux Tapestry, an embroidered cloth that illustrates the events leading up to and during the Battle of Hastings. The comet's appearance was seen as an omen that played a role in the fateful battle that changed the course of English history. Another example is the Great Comet of 44 BC, which appeared shortly after the assassination of Julius Caesar. According to Roman historians, the comet was interpreted as a sign that Caesar's soul had been taken to the heavens and deified. This event reinforced the belief that comets were divine messengers, and it had a significant impact on Roman culture and politics. In 1456, Halley's Comet made another notable appearance, and its passage was linked to the Ottoman Empire's siege of Belgrade. Pope Calixtus III ordered prayers and church bells to be rung to ward off the comet's supposed ill effects, reflecting the widespread fear and superstition associated with these celestial visitors. The Great Comet of 1811, which was visible for an unusually long time and had a very bright nucleus, was also considered to be an omen. Its appearance coincided with significant historical events, such as the start of the French invasion of Russia and the lead-up to the War of 1812 between the United States and the United Kingdom. People at the time saw the comet as a portent of the turbulent times to come. These are just some examples of the profound impact comets have had on human perception and culture throughout history. While today we understand comets as natural phenomena, their historical significance and the myths that they inspired continue to captivate our imagination and remind us of our ancestors' efforts to make sense of the cosmos. Comets have also played a crucial role in shaping scientific thought. In the 16th century, the Danish astronomer Tycho Brahe made detailed observations of a comet and concluded that it was farther away than the moon, challenging the prevailing belief that comets were atmospheric phenomena. His meticulous work laid the groundwork for future astronomers to study comets as celestial objects. Another significant figure in cometary astronomy is Sir Isaac Newton, who applied his laws of motion and universal gravitation to explain the orbits of comets. Newton's work demonstrated that comets followed predictable elliptical orbits around the sun, similar to planets, which was a groundbreaking revelation at the time. His theories allowed astronomers to understand the motion and behavior of comets with greater accuracy. Edmund Halley, a contemporary of Newton, further advanced the field by studying historical records of cometary appearances. He predicted that the comet observed in 1682 would return in 1758, based on its orbital period of approximately 76 years. This prediction was confirmed when the comet reappeared, and it was subsequently named Halley's Comet in his honor. Halley's work established the periodic nature of some comets and demonstrated the power of applying scientific principles to celestial phenomena. In the 20th century, American astronomer Fred Whipple proposed the dirty snowball model of comets, suggesting that they are composed of a mixture of ice and dust. This model was revolutionary in explaining the behavior and structure of comets, including the formation of their tails as they approach the sun. Whipple's insights have been validated by space missions and remain a cornerstone of our understanding of comets today. These astronomers, among others, have significantly influenced our understanding of comets and their place in the cosmos. Their groundbreaking work has transformed comets from mysterious omens into fascinating objects of scientific inquiry, deepening our knowledge of the universe. One of the most famous comets, Halley's Comet, has been observed and recorded by various civilizations for over 2 millennia. Named after the English astronomer Edmund Halley, who predicted its return in 1758, Halley's Comet appears approximately every 76 years. Another well-known comet is Comet Hale-Bopp, discovered in 1995 by Alan Hale and Thomas Bopp. It became one of the brightest comets of the 20th century and was visible to the naked eye for an unprecedented 18 months. Hale-Bopp's extended visibility and brilliance captivated skywatchers and provided scientists with a wealth of data to study cometary compositions and dynamics. Comet Shoemaker-Levy 9 is also famous for its dramatic impact on Jupiter in 1994. Discovered by astronomers Carolyn and Eugene Shoemaker and David Levy, the comet broke into multiple fragments that collided with Jupiter, creating massive explosions and leaving scars on the planet's atmosphere. This event offered a unique opportunity to observe the effects of cometary impacts and underscored the potential hazard that comets pose to planets in our solar system. These comets have played significant roles in advancing our understanding of comets. Comets have also inspired art, literature, and popular culture. They've been depicted in medieval manuscripts, Renaissance paintings, and even modern science fiction. The awe-inspiring sight of a comet in the night sky continues to capture our imagination and reminds us of the dynamic nature of our solar system. For example, the comet of 1577, observed by Tycho Brahe, was featured in numerous contemporary artworks and writings. In the 19th century, the Great Comet of 1811 was immortalized in literature by authors like Sir Walter Scott, who mentioned it in his novel, The Antiquary. In more recent times, comets have made appearances in popular culture, such as in the 1998 science fiction films Deep Impact and Armageddon, which both revolved around the dramatic idea of comets threatening the Earth. The famous Comet Kohoutek of 1973 was featured in music and other media, capturing the public's interest and curiosity. Comets have also influenced the visual arts, with artists like Wassily Kandinsky incorporating comet imagery into their abstract works, symbolizing cosmic and spiritual themes. In literature, Mark Twain famously linked his birth and death to the appearances of Halley's Comet, noting that he came in with Halley's Comet in 1835 and predicted he would go out with it in 1910, which he did. As you can see, comets have left a lasting impact on human history and culture. Let's take a look at some of the most famous comets and their significance to astronomy. The first on our list, as mentioned a couple of times already, is Halley's Comet. It is perhaps the most well-known comet, making an appearance every 76 years. It was last seen in 1986, and it will return in 2061. We also discussed Comet Hale-Bopp, which made a spectacular appearance in 1997, but it too deserves to be on this list. Even though we discussed it earlier, Comet Shoemaker-Levy 9 also deserves to be on the list. Comet Neowise, also known as Comet 2020 F3, captivated observers in 2020 with its bright nucleus and long tails. Discovered by NASA's Neowise mission, this comet was visible to the naked eye and became a social media sensation, with people around the world sharing their photos and experiences. In 2023, Comet C 2022 E3, or ZTF, reached naked eye brightness when it made its closest approach to Earth at a distance of 0.3 AUs, which is about 110 times the distance from our planet to the Moon. Comet ZTF was dubbed the Green Comet. When it was near closest approach, the comet's motion was detectable after a minute or two, depending on your field of view. If you're watching this on YouTube, here's an animation showing the comet's motion over a period of 2 hours and 37 minutes. In that time, the comet moved more than 1 degree across the background stars. For reference, the image is about 5 degrees wide. In the spring of 2024, we had another comet reach naked eye brightness, with Comet P12 Pons-Brooks. This periodic comet, which has an orbital period similar to Halley's Comet, displayed a very active tail and was dubbed the Devil's Comet. Comet C 2023 A3, Shushanshan Atlas, originates from the Oort cloud. It was first detected by the Purple Mountain Observatory in China on the 9th of January in 2023, and independently identified by Atlas in South Africa in February. It is expected to reach its closest point to the Sun at a distance of 0.39 AU on September 27, 2024, potentially becoming visible to the naked eye. However, recent observations suggest that the comet may have fragmented. Comets are known for their unpredictability, and it remains uncertain how this comet will evolve in the coming months. Only time will reveal its fate. Thank you for joining me on this journey through the captivating world of comets. I hope this episode has ignited your curiosity and provided you with a deeper appreciation for these incredible visitors from the outer reaches of our solar system. Until next time, keep looking up at the night sky, and who knows, you might just catch a glimpse of the next great comet. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the AstroGuy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the AstroGuy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. If you'd like to support the AstroGuy Podcast and YouTube channel, you can simply buy us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you again for listening, and may your skies be clear. As always, carpe noctem, seize the night.
I'm Wayne Zuhl, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.